let us discuss root finding methods in this class. Okay. So before that, we should recall intermediate value theorem. Okay. This is the theorem you already studied in PUC. Okay. So whenever you have a continuous function, f of, let's say, f from some interval. So let's say a comma b to r, you have a function, and assume that this f is continuous. Okay. So when f is continuous, let's see the graph of it. So let me assume that the point A is here. So the point A is here, and the point B is here. And if you want to draw a continuous plot from A to B, so what do? First, you see where A is mapped and B is mapped. Okay, to define a continuous function on AB, just join these two guys continuously. So it may not be exactly this one. You can actually go this way, or you can actually go like a snake. All right. So you may go like this, but you need to draw so that it becomes a function. Okay. Whereas you can't actually draw this way. All right. Why? Because my domain, I'm restricting in between A and B. So this is the domain only. All right. So before A it is not defined, after B it is not defined. So the last one is not allowed. All right. So you just join these two guys, and also we are joining in such a way that it becomes a function. I hope you know what is the definition of a function, how to check whether a graph denotes a function or not. How do you check? So we know that. So the image of A must be unique. All right. So one element cannot be assigned to two values. That is the first rule of the function, right? So how do we check it? When you draw a vertical line like this, okay, wherever the graph is there, you just draw a vertical line. It has to intersect the graph exactly at one point. So that is the rule, and that is how you check whether it is a function or not. I hope these basics you must have studied. All right. So now intermediate value theorem, what it says is, when you know the function is continuous between A and B, okay, so then you see what is the value of f of A and the value of f of B. All right. So it means here in this graph, in this particular thing, I'm taking f of A here. All right. And this is the point f of B, so I can take f of B here. All right. So you just take only one graph. All right. So let me take simply maybe this one. Okay. This is the graph I'm taking between A and B. All right. So f of A is assigned to this height, that is f of A, and B is assigned to this height, which is f of B. All right. Now you pick up any point between these two guys, that is K. You assume that that is K. All right. So it means I'm picking up a K so that f of A is less than or equal to K is less than or equal to f of B. So now the intermediate value theorem says that, so there is a point in the domain. So there is a point here related to K, okay, whose image is going to be K. It means you can find some C here so that f of C is equal to K. So this is what intermediate value theorem says. It means whenever the function is continuous on AB, right? So when you take any value between f of A and f of B, okay. So remember one thing: this f of A need not be less than or equal to f of B. For sometimes the graph may looks like this also. For example, you take this graph between A and B, assuming this is A and this is B, and you take a point here. This is f of A and this is f of B. All right. So now you better just join it like this. All right. So now f of A is here. All right, and this guy is f of B. So in that case, I may write it like this. You pick up any k1 in between f of b and f of a. Alright, so now we can say that definitely k1 will be somewhere here. So corresponding to this k1, you can find a point from the domain. Alright, it means you can find some c1 here, which is mapped to k1. That is, there exists a c1 which belongs to the interval, that is a comma b, such that the image of c1 is nothing but k1. Alright, so now you may ask why you are discussing this result now. Alright, because our main intention is this. I told you in the beginning, this class is to find approximate roots of a given equation or a polynomial. Let's assume that you're given with a function f of x. So our interest is to know where this function takes 0. In other words, for example, if I give you this x square minus 1, and if I ask you this question, I'd like to know the values of a. For what values of a, f of a is becoming 0. So what is your answer for this question?
Plus or minus 1.
Plus or minus 1. Yeah. So here you can see that suppose if I take f of 1, you know this is 1 square minus 1. Yeah, it is giving us 0. Alright, so f of minus 1, which is nothing but minus 1 whole square minus 1. So this is nothing but 1 minus 1. So it is giving us 0. So the answer here is a equal to, it can be either plus 1 or minus 1. It means there are 2 points where it is getting 0. Alright, so by looking at this equation, you're able to tell directly. Alright, now let us pick up one more equation. It's like f of x equal to, maybe I'm going to take the x cube minus 3x plus let me take 2. If it is 2, it is so easy. I hope you can tell. Can you tell me at least one value where this function is taking 0? Or it is a cubic polynomial? Simply I'm asking what are the roots of this polynomial. I don't need all roots. At least you tell me one. At least one. One is enough. Yeah. So in my question itself there is answer, right? So that is 1. 1 is a root. Yeah. So here if you observe that f of 1, it's very easy to see. F of 1 will give you 1 cube minus 3 plus 2, and it is 0. Alright. So 1 is one root. Alright. Maybe the other 2 roots you can actually find by factorizing it. Now I'll give you one more equation. At least try to tell it one of its roots. Now f of x equal to, this time I'll take x cube minus 3x only, but I'll take plus 1. Now I change the question. Now your question is, this f of x is given, tell me at least one root. I don't want all roots, just tell me at least one root of it. What do you think? Maybe you can go by trial and error method, like whether 0 is a root. So 0 is not a root here. Maybe you may go for 1, 1 is not, 2, minus 1, minus 2. But if you go for trial and error method, maximum you are checking natural numbers only or integers. Alright. What happens if it doesn't have an integer root? First of all, does it have an integer root? First of all, does it have a root? Because we know there are some equations which never gets 0. For example, if I take this kind of guy, which is f of x equal to x square plus 1, does it take 0 for any real number?
No.
We know it never takes 0, right? Why? Because this is 1, it is positive. X square is also positive. So 1 plus a positive quantity. So you know it is always greater than or equal to 1. Even x is 0, in that case it is equal to 1. The least value is 1 and the highest value it can take any higher. Alright. So we need to decide whether it has root or not. Okay. So now to know whether it has root or not, this intermediate value theorem will help us. And that too, it may not tell you, it may not help you when you have a root with multiplicity. I'll tell you what I mean. See, here you can do one thing. So intermediate value theorem says, let's say if you have a continuous function from on A to B, you take any intermediate value between f of A and f of B, you can always find a point in the domain which is mapped to it. All right. So now what I'll do is I'll take, now I'm going to change the question. Here, instead of thinking about random points, what is it we would like to find? We would like to find root of an equation. And geometrically, we know what is a root. Geometrically, the root is nothing but if you draw a plot for this function, all right, you need to know where it intersects the x-axis, isn't it? You'd like to know the location, I may call it as xi, for which f of xi is getting 0. All right. Suppose if the graph looks this way, then definitely left side of xi you may find a negative quantity. All right, and the right side we will have a positive. It means the function will change from negative to positive, or it may happen the other way also. It may change from positive to negative. So in these two cases, we are sure that it is taking 0 between these two values, isn't it? But whereas there is one more situation, there intermediate value theorem may not help us. That situation is nothing but this one. All right. So here it touches the x-axis, whereas it is not intersecting. All right. So it, and you know what kind of equation is this? Let's say if I assume this point is 2, and this is nothing but the function is nothing but f of x equal to, which is x minus 2 whole square. And you know that here 2 is a root. Maybe that 2, this 2 you may confuse, so let me take 3 here, that would be better. So let me take 3 here. All right. So now it is very clear that 3 is a root of f of x with multiplicity 2. Okay, so with multiplicity 2. But in this case, you see it is not going from positive to negative or negative to positive. It is actually the left side is also positive and right side is also positive. All right. So this situation, intermediate value theorem may not help us. Okay, but whenever if we have these two kind of situations, intermediate value theorem will help us. The moment you know the function is continuous and you search for an interval a comma b where f of a into f of b is negative, because when product of two expressions will be negative, product of two expressions is negative whenever they have the opposite signs. I mean, for example, if you multiply -1 and 2, then you will get -2. You will get a -1. All right. So if you multiply a positive quantity and a positive quantity, then you will get a positive quantity only. But a negative quantity multiplied with a positive quantity, this will give you negative quantity, isn't it? So similarly, a positive, you must have seen in 10th class, like plus into plus, minus into minus. The same kind of thing I'm writing here. So positive into negative, this gives us a -1. So negative into negative, and it gives you positive. Now what is our interest? We would like to know the interval where the sign change is occurring. It means f should move from positive to negative or negative to positive. So in that case, we do expect that either f of a is positive and f of b is negative, or we do expect f of a is negative and f of b is positive. Okay, so in these two situations, if you observe f of a into f of b, this is always negative. All right. So now to locate to find an interval in which root contains, you search for a comma b, where f of a into f of b is negative. Okay, so let us do one thing. Whatever I have written here, that's what let me take and let me search for it. So this is the function we have taken. Now I would like to find the interval where root lies. All right, so for that I'll do one thing. First I'll see what is f of 0. F of 0 is nothing but 1, so this is positive. Next, let me see what is f of 1. What is f of 1 here? 1 is nothing but 1 minus 3 plus 1, and you can see this is minus 1. Now it is negative. Now we are lucky. Initially itself we got. It means what? So between 0 and 1, the function is taking the value 0. It means if you plot this, if you plot the graph of the function, right, let me assume this is the point 0 and this is the point 1. Okay, so at 0 the function is taking the value 1, whereas 1 it is taking the value minus 1. Now somehow you need to join this point continuously. Okay, so somewhere in between 0 and 1 it has to take 0. So now we need to find that location C, for which f of c equal to 0. But one thing is clear here. What is it? Since f of x is a polynomial, it is continuous. Therefore, using intermediate value theorem, we can conclude that there exists at least one c which belongs to the interval a comma b such that f of c equal to 0. In other words, simply we can say that there exists a root of f of x in the interval 0 comma 1. All right. See, here I have written at least. Why? Because you may have more than one root also, because the graph may be like this also, isn't it? So in this case, you can see 1, 2, 3. There are 3 roots. If the graph is this, okay. Now let us try to approximate the root, initially using bisection method. It is there in the name itself what we are going to do. You're going to bisect the interval. All right. So let me walk through a problem first. Initially you are given with this function, right? So f of x equal to x cube minus 3x plus 1. I am taking the same function. Okay. So now here f of 0 is 1, whereas f of 1 is minus 1. Therefore, there exists a root of f of x in the interval a comma b, that is nothing but 0 comma 1. All right. So now our initial approximation. So initial approximation. Let me assume that is x naught. See, we are saying that between 0 and 1 there is a root, right? So what is that root? Okay, now I am telling that approximately that is a middle point. How do you find the middle point? You will take a plus b and you take half of it, isn't it? When you assume this is a and b. All right. So the initial approximation is a plus b by 2. So which is nothing but 1 by 2. And you know this is 0.5. Okay, so now I'm saying that root of this function approximately is 0.5. That may not be the exact root. Okay, when you substitute this 0.5, the value may be close to 0. That's it. That's all I can say here. All right. Now I want to make it more accurate. Okay. So if you want to make more accurate, you reduce the error. How do you find the error actually? The exact error can be found like this, right? If you have an exact value, if you know the exact value minus approximate value will give you the error, isn't it? But here, to calculate the exact error, we don't know what is the exact value. So now how do we estimate the error? Now what I know is, I know what is the distance, what can be the maximum distance between the root and approximated root. So here, all I can say here is, so exact root, the distance between exact root and approximated root. That is nothing but you assume that the exact root is I and the approximated root is x naught. What I can say is the maximum distance is 1 by 2. Why is it? Because initially our interval length is 1, no? Our interval length is 1, 0 to 1. And we know between 0 and 1 there is a root. It means, let me assume that exact root location is this. This is the exact root location. And where is our approximated root? Which is here. I'm taking 0.5 to be approximated root. Now you see what is the distance between exact root and approximated root. All I can say is it is less than this distance. What is this distance? Which is exactly 1 by 2. Alright. So now if you want to calculate the accuracy here, length of this interval, not exactly a comma b, I'm talking about the other one, a comma maybe a plus b by 2. Alright, now this will tell you the accuracy of the root. So now to find the next one, what shall we do? To find the next approximation, now we will update the interval a comma b to maybe 0 comma 0.5 or 0.5 comma 0 comma 1, depending on root. So let me assume at 0 this is positive, we already found, and at 1 it is negative. At 0.5, can you tell me what is f of 0.5 here? F of 0.5, what will it be?
Minus 0.375, sir.
So okay, I don't need its value also. I just would like to know whether it is negative or positive. So it is negative. So we observe that this is negative. Alright. Now where is the root of this function? Where do you expect? Between 0 and 0.5 or 0.5 and 1? So what is the new interval you are going to take? So is it 0 comma 0.5 or 0.5 comma 1? In which interval root lies? See here the function takes positive value, whereas here it takes negative value. So between positive or negative, what do you expect? Yeah, what is it? Repeat again.
The root might lie between 0 and 0.5.
Yeah. So we can say it lies. No need of using may also, because it is here it is 0 positive, at 0.5 it is negative. So definitely there exists at least one root between 0 and 0.5. Yeah. So our new interval is this. So now what we will do, we will update the interval, that is a comma b. We will update it to this one. What is it? A comma x naught. Okay. So that is what exactly 0 comma 0.5. Right. So now, so we are going to find the next approximation. You may call it as x1. That is exactly midpoint of these two, that is 0 plus 0.5 by 2. And what is it? Which is 0.25. Alright. So now let us see what is the distance between exact root and approximated root. Okay, in the next iteration, whatever steps we are doing, we can call them as iterations. So in the next step, what is it you get? The distance between xi and x1, which is less than. So what do you see? What is the distance between the exact root and approximated root?
It is less than 0.25.
Yeah, it is less than 0.25. Or in other words, you can say it is less than 1 by 4. Why? Because earlier we approximated 0.5 is the root. Alright. So now the distance between the exact root and approximated root is less than 1 by 2. Now, so the total length of this interval is actually 1 by 2. Alright. But in which we know either, the root either lies here or here. Okay. So now I just need to calculate length of this interval. Alright, any one of them is fine. Either you calculate this length or this length, both are same, no? So now this length is actually 1 by 4. Therefore, the distance between exact root and approximated root is less than 1 by 4. Or you can write it as half of 1 by 2 whole divided by 2, it is same as 1 by 2 square. Okay. Suppose if I proceed and if I go for the next iteration also, what is it you get? You get x2. Okay, x2. So earlier we are at 0 and 0. Okay, I need to know what is the value of the function at 0.25 to know x2. So for this, let me see what is f of 0.25. It means what you have to do is 0.25 whole cube minus 3 into 0.25 plus 1. Yeah. So what is it? What is the value? Negative or positive? Just you tell me that.
Positive, sir.
Okay. So it is positive. All right. So now again. So let me take this interval. So the interval is 0. Earlier our interval is 0 and 0.5. So here you know it is positive and here you know it is negative. Again at 0.25, so you know the value is positive. So now where do you expect the root? Between 0, 0.25 or 0.25, 0.5?
Between 0.25, 0.5.
Exactly. So our new interval is 0.25, 0.5. Now what we can say is root of f of x lies in 0.25, 0.5. Now you can get the next approximation. So you take midpoint of this. Okay. So midpoint of this, let me take it as x2. Now x2 equal to, that is 0.25 plus 0.5 whole divided by 2. Alright. Now what is it? So 0.375. Alright. Now what is the accuracy? It means what is the distance between the exact root and x2. So we can say that it is less than. Now what happened? Again you bisected the interval, no? Now interval length is going to be reduced by half. So earlier the length was 1 by 4, again you bisected it, so 1 by 2, so it is 1 by 2. So similarly, if I proceed further, can you tell me what is the accuracy at the end step? That is xi minus xn is less than 1 by
2 power n plus 1.
Yeah, 2 power n plus 1. You can actually see if you get 2 here, you got 3 here, 2 plus 1. So earlier we got xi minus x1 is just 1 by 2 square. It means 2 power n plus 1. Alright, so in the nth step, so this is the accuracy if you use bisection method. Alright, so now you may get one question, sir, how many steps or how many iterations we need to do it here to find the approximate root? It depends on the accuracy, how much accuracy you require. For example, I want the accuracy, let me call it as epsilon. So I want the accuracy which is to be 0.03. Alright, so this is the accuracy I'm expecting when you approximate a root. It means the distance between the exact root and approximated root is, it has to be less than epsilon. Okay, but if we use this method, we know what is the distance between these two guys. Alright, so just for convenience, let me do one thing. Let me take n minus 1 step, so it is easy to write the guys. So this is n minus 1. So I want this to be less than epsilon. So now here we already know that the distance between xi and xn minus 1 is less than what? 1 by 2 power n. If you have n here, you will have n plus 1. Whereas if you have n minus 1, then it will become n. So now this, so if you can make this one is less than epsilon, then okay, we got this one. Alright, so xi minus xn minus 1 is going to be less than epsilon. So now if you want to have this much of accuracy, you just do one thing, you try to find n such that 1 by 2 power n is less than epsilon. Okay, so if you want now we want to find n so that this 1 by 2 power n is less than epsilon. Alright, where epsilon is the desired accuracy. Alright, so now let us try to convert it. I mean, you can rewrite it like this. You can rewrite it like 2 power n is greater than 1 by epsilon. Okay, so what I have done is I have just taken reciprocal of it. Alright, so I hope you know whenever a is less than b, that implies 1 by a is greater than 1 by b. When you take reciprocal, the inequality changes. Alright, so of course I am assuming both are of same sign. 1 by 2 power n is positive, and epsilon we are saying it is an accuracy, so definitely we will take this to be positive, so there is no issue. Now this implies you apply logarithm on both sides, so that is ln of 2 power n is greater than ln of 1 by epsilon. Now this implies n into ln 2 is greater than ln of 1 by epsilon. So now this implies n must be greater than ln of 1 by epsilon divided by ln 2. Okay, and using some more simplification, you can write it as ln of 1 by epsilon to the base 2. But anyway, you better leave it like this. Okay, so if you want accuracy to be epsilon, and you need to take n number of steps. For example, here I want accuracy to be 0.03. Let me assume that the initial interval I started is of length 1. Okay, and one more thing, here whatever calculation I did, it is for length 1. If you start with a comma b, where the distance between a and b is 1, then only this formula works. Okay, whereas if you start with an arbitrary interval a comma b, in that case what you have to write here is, let me explain here. You see here, initially I have taken the interval 0, 1. It means a equal to 0, b equal to 1. So b minus a is 1. So that is why we have written just 1 by 2. Suppose if you don't know what is A and B, generally what do you write here? Length of the interval. Length of the interval is going to be B minus A. Okay. So in the next step, the interval length is going to be B minus A by 2. Don't get confusion between the approximated root and the distance. This is actually measuring the distance, okay? So if you start with an interval that is A comma B, in that case, the formula must be written like this. Instead of writing 1 here, you must write B minus A. Okay. So here I'll have B minus A. Let me quickly rewrite it. This is B minus A by 2 power n, and we want this to be less than epsilon. Alright. So the only change I need to make is here. So this divided by, you might get B minus A. Alright. So this B minus A, you can multiply with B minus A because we always take B to be bigger than A. Or in other words, you take a modulus, no issue. So it is positive. When you multiply with a positive quantity, there is no change in the sign. So B minus A goes here. So this is actually mod B minus A by epsilon. Alright. So now here you'll have B minus A. Okay. See, for example, let's see with an example. Suppose our initial interval, that is A comma B, it is given, let's assume 3 comma 5. Our initial interval itself is 3 comma 5. Okay. Now they are asking us to find xi. Okay. That is a root of f of x, which lies in the interval which lies in the interval 3 comma 5. Okay, and this f of x may be some function which has root in 3 comma 5. I'm not taking the same function, be careful, this is not same as earlier function. Okay, this is some arbitrary function which has root in the interval 3 comma 5. Now, so how many steps we need to take in the bisection method so that the distance between exact root and approximated root is less than 0.3 or 0.3. So now this is the question. So the question is how many steps we need to take bisection method to find root with an accuracy 0.03. So this is the question. Alright. So now we had a formula in our hand. So this is the formula we are going to use. So now the formula suggests me that you try to find an n. Alright. You just find an n which is greater than ln of b minus a by epsilon divided by ln2. So it means this is what I need to find. Ln of here a comma b is nothing but 3 comma 5. So let me write. So this is 5 minus 3 by epsilon is 0.03 divided by ln. So can you tell me what is its value? Okay, we got 6.05. Very good. So therefore we got n must be greater than 6.05. So what is the natural number after 6.05? Therefore that is 7. So we must take at least 7 steps to get this accuracy. Okay, if you take more than 7 steps like 10 steps or 12 steps, yeah, you will get much more better accuracy. That means the distance between that is maybe less than 0.001. But anyway, to get this accuracy, fine. 7 steps are enough. That's it. 7 steps are enough to do. All right. So if you are asked to solve a problem using bisection method with uh, with some accuracy, first you need to find n using this formula. So after finding n, you proceed for the calculation. All right. And let me tell you how to simply solve this problem using a table. Like, because every time writing x2 like this, it's maybe it looks lengthier, but when you write in a table, it looks better. So here I'm taking f of x equal to x cube minus 3x plus 1. Okay. So now the question is to find. So first you do one thing. Initially this procedure is same. We are going to search for an interval where the root lies. So f of 0, you can see that is 1. So it is positive. F of 1, and it is minus 1. You know this is negative. Therefore, you know that using intermediate value theorem, you better mention it there. Okay. So there exists a root of f of x in 0, 1. All right. So after writing this, now you create a table. So if you want, you can keep the serial number. Otherwise, no need. So initially, you can pick up the interval. Okay. So instead of saying an interval, you better take the a value and the b value where the root lies. You better write it in an increasing order. Okay. And later, you write what is x naught. It means the midpoint of those two, which is a plus b by 2. Okay. And later, you see what is the sign of f of xi. So let me write I here, just for a general one. Okay. You see what is f of xi. Okay. So depending upon that, you're going to update. You're going to write the new a and new b. All right. I hope I don't need these guys unless you want to write the error, because here error is prefixed if you know the interval. Okay, so let me include serial number also. Good. Okay. So initial interval a is 0, b is 1, and the midpoint is 0.5. And here no need of writing the value of the function. If you want to, you write it. Otherwise, you write whether it is positive or negative. But so not to have confusion, just I'm writing f of 0.5. You already told me that is something 0. How much? 6, negative 0.6. Am I correct?
Zero point 375.
0.37. No, I'm asking about f of 0.5. It means 0.5 whole cube minus 3 into 0.5 plus 1. How much is it? Minus 0.375. Okay, earlier I saw it like 0.6. Anyway, minus 0.37. Okay, so all that I need is whether it is positive or negative. That's it. Okay, so just for convenience, I'm writing here its signatures. So at 0, it is positive, and here it is negative. So what we get here, we got negative here. So which one you change? Whatever you get, no, if you get negative, you just change that. So you write 0 as it is. Okay, so we write 0 as it is, but f of at 0.5 we got negative. So now you update this 1 to 0.5. Now I hope you know at 0 it is positive, and at 0.5 it is taking negative value. Definitely root lies between these two. So now midpoint of these two you need to write in the next step. So this you may call it as x naught. Okay, and you may call it as x1, So x1 is nothing but 0.25. Just for clarity, I'm writing, okay? This is 0 plus 0.5 by 2, which is 0.25. No need of writing this way. Directly you can write 0.25. Alright. So now you see what is f of 0.25. I hope we found that is positive, right?
Yes.
You better write the value also. Yeah, 0.2656. Alright. Let me write. I'm interested in knowing its signature. That's it. I don't want the value really here. Okay. So we know it is positive. All right. So since it is positive, so what is it you're going to update? So we update the positive guy only. Earlier 0 is positive, no? So you just update that. So here now the new value is 0.25 and here 0.5. This is our new interval. So here it is positive. You know the function takes negative here. Now you write what is x2. X2, that is 0.375. I'm really getting a doubt. Is f of 0.5 0.375? Please confirm. Okay, if the answer is yes, fine. Okay, so here you got x2. Now again you are going to see f of 0.375. So is it positive or negative? You tell me. If you tell its value, that is
Negative, sir.
also fine. Okay, minus 0.07. All right, it is negative. All right, so you can see that the guy is negative here. Okay, so if it is negative, what will you do? So next, in the fourth step, so negative 1 I need to update. So the positive one you carry as it is 0.25 and the negative one is changed to 0.375. Okay, so although the problem is very simple, uh, uh, some students used to do mistakes in the exam because you know the updated value, what do they keep is they are going to keep this instead of this. Okay, so be careful, don't do that mistake. So if you want to avoid that mistake, you better don't write what is the value of it. You just write whether it is positive or negative. Okay, so that you don't have much confusion what to write. Okay, so now f of 0.25, you know, here it is positive, here it is negative. What is x3? Computer, tell me what is x3. So that is midpoint of 0.25 and 0.37. So 0.3125. Okay, so now again you're going to see what is f of 0.3125. Just tell me whether it is positive or negative. Positive. All right. So this is positive. All right. So now suppose if you suppose if we get n value is 5. Okay, in the fifth iteration we need the root. So what is the updated guy? So this one I should update that. 0.3125 and this is 0.375. Okay, so this I need to update, right? So now x4, so x4 is nothing but, what is x4? So definitely 0.3, 4375. Okay, so now if I see, okay, suppose if I want accuracy to be maybe let's say here given that epsilon equal to 0.02. If the epsilon is 0.02, is it enough? Is x4 is enough, or should I proceed further? So if epsilon is 0.02, you do one thing. First you calculate what is n. So n must be greater than ln of b minus a by epsilon by ln2. Okay. So where b minus a is actually our first interval. Here whatever we are writing here, this is what you must take it as a comma b, initial interval. All right. So the initial interval length we always prefer it to take one only. So this equal to ln of 1 by 0.02 divided by ln2. I hope you can calculate without using calculator also. Alright, so n must be greater than, I hope you can write it like this, ln of what is it, 0.02, right? So using properties of logarithm. So n must be greater than, we can write it minus ln of 2 into 10 to the power of minus 2 into ln. Yeah, but yeah, we need actually calculate, because this minus 2 is there and only to the power of 10. It's not for 2 anymore. So finally, what is it? So this is, so it is 5.64. Alright. So therefore, n must be equal to 6. So we need to find till x6. Okay. So you please continue the table and tell me what is x6 now. So with that we will stop. You tell me what is x5 and x6. I hope I'm audible, right? I'm asking you what is x5 and x6. See, if you are giving answer, you don't round it to 2 decimal places. Okay, you tell me whatever you get there, even if it is 6 decimals or 7 decimals, no issue. Anyway, you had already 5 decimals here. You may get 6 or 7. In bisection method, you should not reduce the digits. Okay, whatever you obtain, that's what exactly you should write in bisection method. So good. There is an answer. X5 is 0.359. Wait a minute. Let me write. 0.359 B7. Okay, good. And x6 is 0.353437. So now this is the root with an accuracy 0.02. It means if you see what is the distance between the exact root and x6, we are sure that it is less than 0.02. It means up to 1 decimal place, it is agreeing with the root. Okay, and when you go to the second decimal place, the error is it is maximum 2, like that. Okay, so I hope you understand how to find a root using bisection method. All right. So here the mostly you may have you may have this question, like if you have a multiple root, then what do you do? If you have a multiple root, or in one interval if you have more than 2 roots, then what about this bisection method? Okay. So what I mean, I'm talking about this. Let's say you have an interval. You have an interval a comma b. You came to know that here it is positive and here it is negative. But it is what happened here is one root is here, another root is here. There are actually two roots in the interval. So when you bisect it, what happens? So when you bisect it, so what happens here? So definitely either it is positive or negative. One should come. You can't have both positive or negative. Alright. Suppose if you have positive here, what happens is you may find only this xy2 and you may not be able to find the xy1. But if you get negative, we may find only xy1. Okay. You may ask me, sir, how is it possible to have such a graph? Like the root here and the root here, whereas the positive here? Yes, it is possible. Let me draw it like this. So let me draw the graph like this. Okay, so here let it come down. Okay, I said it is negative here. Okay, now you see the graph. So here it is positive. So here it is actually negative. But what I told you. Okay, let me just change according to the graph. So here it is negative. All right. So it means if we apply bisection method here with this interval a comma b, the root converges to xy1 only. It will not converge to xy2. Okay. So if you want the root to converge to xy2, what you have to do is you need to pick up this interval. So that interval is actually here. This interval you may need to pick up, but that might be very, very small. Okay. But the expectation here is it's not that you're going to do it on a paper, right? So our expectation is we need to write a program. Okay. So you're all CSE students, you must write a program for this bisection method. Okay. So whatever language you use, either Python or C, you write a program for bisection method and you execute. All right. And you try to come with a good program so that it can identify if it has two roots in the interval. All right. So with this, I'll stop and let me know if you have any questions or doubts. And one more thing, let me tell you. And bisection method fails. I mean, if you have a kind of graph like this. Fails, I mean, there is a root. A is a root of f of x, but using intermediate value theorem, I'm not able to identify the interval using intermediate value theorem. All right. Even we cannot apply bisection method here. Why? Because what happened? It's not taking negative positive values, right? So in bisection method, it purely depends on whether f takes negative or positive. All right. So in this case also we cannot apply bisection method. Not only bisection. The next we are going to discuss. What is regular-Paulsen method and Newton-Raphson method. Newton-Raphson methods can be applied here, but no, cannot be applied. If you have multiple roots, that also cannot be applied. So the three methods, whatever you are studying here, that cannot be applicable for this kind of problem. Okay, and I'll tell you what is the method that can be applied, but which is not in the syllabus. Yeah, I'll stop it here and let me know if you have any questions or doubts.